Today we'll start Laplace transform. So revision. So here Laplace transform, it is defined for positive values. So if f of t is a real valued function, so defined for all t greater than equal to 0. Greater than equal to 0 means it is defined for positive values. Greater than equal to 0. Positive values. It is defined for positive values. Then the Laplace transform of f of t is denoted by L of f of t. So here L is a Laplace transform operator. L is Laplace transform operator. So Laplace transform of function f of t is denoted by L of f of t. This L is a Laplace transform operator and it is defined as integration from t is equal to 0 to infinity e raised to minus st f of t dt, provided the integral exists. So you integrate and substitute the limits, you will get a function of s and t. When this is evaluated, when t is equal to infinity, so we left with a function of s, and this is denoted by f bar s, or sometimes it is also denoted by capital F of s also. F bar s or capital F of s, right? So once again I'll explain. So Laplace transform, it is defined for positive values. So L is a Laplace transform operator. Laplace transform of function f of t is equal to integration from t is equal to 0 to infinity e raised to minus st f of t dt. So you integrate this. So you will get a function of integrate and substitute the limits as t is equal to 0 to infinity. So you will get a function of s, and it is denoted by capital F of s or f bar s. Then what will be the definition of Laplace transform of function? Integration from t is equal to 0 to infinity e raised to minus st f of t dt, and it is defined for positive values, and it is defined for positive values. T greater than equal to 0 means, and it is defined for positive values, right? So with this, so we'll discuss some elementary functions of this Laplace transform. So in that first one, so Laplace transform of A. So what is A here? A is a constant, right? Again, by definition only. We know that Laplace transform of f of t is equal to integration from 0 to infinity e raised to minus st f of t dt. So this will be the definition of Laplace transform. In place of f of t, so we have A, because we need Laplace transform of A. In place of f of t, so we want A. So Laplace transform of A. So in place of f of t, you substitute A. So Laplace transform of A is equal to integration from 0 to infinity e raised to minus st. In place of f of t, you substitute A. So A dt. And here A is given that constant. You take it outside because we are integrating with respect to t. So A is like a constant. Take it outside. Integrate A outside. Integration from 0 to infinity e raised to minus st dt. So integrate this. So e raised to minus st. Integration of e raised to minus st is e raised to minus st divided by minus s. Limits varies from 0 to infinity. E raised to ax with respect to x is e raised to ax divided by a. So e raised to minus st with respect to t, e raised to minus st divided by minus s. Limits varies from 0 to infinity. So we need to substitute the limits for t. Right, in place of t, you substitute upper limit as infinity and lower limits as 0. So denominator minus s, it is like a constant, take it outside. This denominator we have minus s, so we'll get here as minus a by s, and substitute limits here. In place of t, upper limit e raised to minus s into infinity. So this will be e raised to minus infinity. We have a standard result. E raised to minus infinity is 0. minus. In place of t, you substitute 0, e raised to minus 0. E raised to minus 0 is 1. This minus is plus. A by s into 1 is a by s. So Laplace transform of a is a by s. And here s is greater than 0, means it should be positive. So in particular, in place of a, you substitute 1. So Laplace transform of 1, this is equal to, in place of a, you substitute 1. So this is 1 by s. So standard result, Laplace transform of 1 is equal to 1 by s. Laplace transform of 1 is equal to 1 by s. It is a standard result. And Laplace transform of a is a constant. So Laplace transform of constant is constant divided by s. Please remember this. Laplace transform of a is constant, right? Laplace transform of constant is constant divided by s. Whatever it may be, Laplace transform of constant is constant divided by s. And Laplace transform of 1 is 1 by s, right? And now move on to second one. So Laplace transform of e raised to at. So these are the standard results. So Laplace transform of e raised to at. So here in place of f of t, what we have? E raised to at. Again by definition, Laplace transform of e raised to at is integration from 0 to infinity e raised to minus st. In place of f of t, e raised to at dt. Right? Now base is same. Base is same. We can take here t as common for both the terms. We can take t as common both the terms and base is same. So we can write this e raised to minus st e raised to at as base is same, taking this minus outside, inside, and t is also common for both the terms, s minus a into t dt, right? Yes, so we'll write this e raised to minus st e raised to at as this will be same integration from 0 to infinity e raised to minus, and this t is common from these two, take common from these two terms. So inside will be s minus a, and this e base is same. Base is same, right? By using theory of indices. Now integrate this with respect to t. So how it is like? It is like integration of e raised to ax with respect to x. Integration of e raised to ax is e raised to ax divided by a. In the same way, in place of here ax, a is s minus a, x is t, right? So we'll get integration of this as e raised to minus s minus a into t divided by minus 1 minus s minus a. Now limits varies from 0 to infinity. So see the denominator. So it is free from t. Take it outside, because we are substituting limits. In place of t, we are substituting. So in place of t upper limit and in place of t lower limit. Take this minus 1 upon s minus a outside, and in place of t you substitute infinity. So you'll get this as e raised to minus infinity as the upper limit. E raised to minus infinity is 0, and in place of t substitute lower limit 0. So e raised to minus 0 is 1. Minus 1 upon s minus a, and this 0 minus 1 is 1, right? Sorry, 0 minus 1 is minus 1. This minus 1 divided by s minus a, and this minus 1 will be 1 upon s minus a. This minus into minus is plus 1 upon s minus a. So Laplace transform of e raised to at is 1 upon s minus a. Right? Now move on to next one. Laplace transform of cos hyperbolic at. So we have a standard result. So we can convert this hyperbolic functions into exponential. So I will take advantage of that. So we know that cos hyperbolic at is equal to e raised to at plus e raised to minus at divided by 2. Right? Now apply Laplace transform to this. Right? So Laplace transform of cos hyperbolic at, 1 by 2, take it outside. It is like constant, take it outside and apply Laplace transform for both these terms. So Laplace transform of e raised to at plus Laplace transform of e raised to minus at. Now take separately Laplace transform for both the terms. So 1 by 2 into Laplace transform of e raised to at plus Laplace transform of e raised to minus at. Right? 1 by 2, this is as it is. So we have a result, standard result. Laplace transform of e raised to at is 1 upon s minus a plus Laplace transform of e raised to minus at is 1 upon s plus a. Laplace transform of e raised to minus at is 1 upon s plus a. Why? Because we can write this as, this in place of Laplace transform of e raised to at is 1 upon s minus a. So in place of a we have a minus a. So s minus of minus a will be s plus a. Please remember this. Laplace transform of e raised to at is 1 upon s minus a and Laplace transform of e raised to minus at is 1 upon s plus a. Minus at 1 upon s plus a plus at 1 upon s minus a. Now take LCM. LCM will be s minus a, s plus a. S minus a is there, multiply s plus a. S plus a is there, multiply s minus a. So 1 into s plus a is s plus a and this positive sign is as it is. And 1 into s minus a is s minus a. So these two plus a minus a get cancels. S plus s is 2s and observe the denominator here, s minus a, s plus a. How it is like? A plus b, a minus b. A plus b, a minus b is a square minus b square. S minus a, s plus a is s square minus a square. So Laplace transform of cos hyperbolic at is 1 by 2. S plus s is 2s because a plus a minus a get cancels. 2s divided by s square minus a square. So 2 get cancels. Laplace transform of cos hyperbolic at is s divided by s square minus a square and here s is greater than e. S should be greater than e. Right? Now move on to next one. Laplace transform of this a sine hyperbolic at. Right? Again hyperbolic functions. So we have a standard result. Sine hyperbolic at is equal to e raised to at minus e raised to minus at divided by 2. So take advantage of this hyperbolic functions. So we can convert this hyperbolic functions into exponential. So using that sine hyperbolic at is equal to e raised to at minus e raised to minus at divided by 2. Now apply Laplace transform to this. So Laplace transform of sine hyperbolic at is equal to Laplace transform of e raised to at minus e raised to minus at divided by 2. So take 1 by 2 up, 1 by 2 outside and apply Laplace transform for both the terms. So Laplace transform of e raised to at minus Laplace transform of e raised to minus at. So 1 by 2, this is as it is. So we have a standard result. Laplace transform of e raised to at is 1 upon s minus a. This minus will be as it is. Laplace transform of e raised to minus at is 1 upon s plus a. Now take LCM. S minus a, s plus a. How it is like? It is like a plus b, a minus b. A plus b, a minus b is a square minus b square. So in place of a, we have a s. So s square minus a square. So s minus a is there, multiply s plus a. S plus a is there, multiply s minus a. And here plus s minus s get cancels. A into a is 2a. 1 by 2 into 2a divided by s square minus a square. So 2 get cancels. So Laplace transform of sine hyperbolic at is equal to a divided by s square. A divided by s square minus a square. So where s is greater than a. Now move on to next result. So fifth one, Laplace transform of cos at. So in place of f of t cos at we have. So again, by definition, Laplace transform of cos at is equal to integration from 0 to infinity e raised to minus st in place of f of t cos at dt, right? Now we need to integrate. So it is a product of two functions. One is exponential and other is trigonometric. So we have a standard result. So integration of e raised to at cos bt dt is e raised to at divided by a square plus b square into bracket a cos bt plus b sin bt. Now I'll take advantage of this. So in place of a, we have minus s. In place of a, we have minus s, and in place of b, we have a. So substitute. So we'll get here as Laplace transform of cos at. This is equal to e raised to minus st divided by minus s raised to 2 plus a square, means e raised to at divided by a square plus b square, e raised to minus st. In place of a, minus s. In place of b, we have a e raised to minus st divided by minus s raised to 2 plus a square into bracket a minus s cos bt cos at, because b is a, plus b is a cos sin bt sin at, right? B is a is minus s cos at plus a sin at. Limits varies from t is equal to 0 to infinity. Again, denominator free from t. In place of t, we are substituting limits. So minus s raised to 2 is s square plus a square. Take it outside because it is free from t. Now we need to substitute limits for these two, e raised to minus st minus s cos at plus a sin at. Limits varies from t is equal to 0 to infinity. Now substitution of limits. So always upper minus lower. In place of t, substitute infinity, e raised to minus infinity. We have standard result, e raised to minus infinity is 0. 0 into something is 0. So this is upper limit is over. Minus lower limit, in place of t, you substitute 0. E raised to minus 0 is 1. Minus s cos 0 is 1. Right? The minus s into 1 is minus s, and sine 0 is 0. 0 into something will be 0. Right? So e raised to 0 minus s cos 0 plus a sine 0. Upper limit e raised to minus infinity 0. Right? Lower limit, in place of t, substitute 0. Right? We'll get here as, here sine 0 is 0. So this term will be 0. Left with what here? This and this. E raised to 0 is also 1. Cos 0 is also 1. Minus into minus is plus. So Laplace transform of cos at is s divided by s square plus a square, where s should be greater than 0. Now move on to next one, Laplace transform of sin at. So again, in place of f of t, sin at. So Laplace transform of sin at is equal to integration from t is equal to 0 to infinity e raised to minus st sin at dt. Right? In place of f of t, we have substituted sin at in definition. Right? Only that much. Again, we are using the standard result. Integration of e raised to at sin bt dt is e raised to at divided by a square plus b square, a sin bt minus b cos bt. Right? Now, in place of a, we have minus s. In place of b, we have a. So substitute. So Laplace transform of sin at is equal to e raised to minus st divided by minus s raised to 2 plus a square minus s sin at minus a cos at. Limits t is equal to 0 to infinity. Always upper minus lower. Denominator s square plus a square, because minus s multiplied 2 times. So minus s raised to 2 is s square plus s square, because minus into minus is plus, and this a square will be as it is. E raised to minus st minus s sin at minus a cos at. Limits t is equal to 0 to infinity. Always upper minus lower. Upper limit is infinity. E raised to minus infinity is 0. So 0 into something will be 0. Minus, in place of t, substitute 0. E raised to minus 0 minus s sine 0 minus a cos 0. So here sine 0 is 0. So this term will be 0. E raised to 0 is 1. And this minus into minus is plus. And cos 0 is 1. So you'll get this as Laplace transform of sine at. This is equal to a divided by s square plus a square, where s is greater than 0. And next one, very important one, Laplace transform of t raised to n. So many times we use this result. So we know that Laplace transform of t raised to n is integration from 0 to infinity e raised to minus st t raised to n dt, right? So in place of ft, in place of f of t, so we have substituted t raised to n. Now we need to integrate this. So for that, so I'll use substitution method. So put s into t as a x, right? So we want dt means differentiate. So dt is equal to dx divided by s. Once we are changing the variable means here limits also changes. So t varies from 0 to infinity. So we are substituting s into t as a x. So here x is also varies from 0 to infinity, because in place of t, you substitute infinity, so you'll get x as infinity. In place of t, you substitute 0, so you'll get x as a 0. So x is also varies from 0 to infinity. So Laplace transform of t raised to n. So in n is equal to integration from x is equal to 0 to infinity e raised to minus x by s raised to n dx divided by s, right? st, we have taken this as a x, so e raised to minus x. T raised to n we want, so s into t is x. We want t, so t will be x by s. So x by s raised to n. And dt we want, so dt is dx divided by s. And in place of t, we have x here, because we are changing the variable here t to x. So x is equal to 0 to infinity, right? Now simplification and integration. Now see here, we are integrating with respect to x, right? So denominator this s and this s, it is free from x, take it outside, because here x raised, we can write this x by s raised to n as x raised to n divided by s raised to n. So this s raised to n and this s raised to 1. So by using theory of indices, base is same. So we can write this as s raised to n plus 1. So denominator we have, take it outside, 1 upon s raised to n plus 1. Integration from x is equal to 0 to infinity. This e raised to minus x, this will be as it is, x raised to n, right? Because denominator we have taken outside, right? Dx. Right. Now we have a standard result by using beta and gamma functions. This will be denominator as it is, 1 upon s raised to n plus 1, and integration from x is equal to 0 to infinity e raised to minus x raised to n dx. This is nothing but gamma n plus 1. This is nothing but gamma n plus 1, right? So using that, so in place of this integration from x is equal to 0 to infinity e raised to minus x raised to n dx, in place of this substitute gamma n plus 1. So Laplace transform of t raised to n is gamma n plus 1 divided by s raised to n plus 1, where n is a constant, right? Again, we know that one note, simple one, and this we use many times while solving example, right? Now note, we know that gamma n plus 1 is equal to n factorial, right? So it's a standard result from beta and gamma functions. So Laplace transform of t raised to n, this is equal to, in place of gamma n plus 1, so substitute n factorial. So Laplace transform of t raised to n is equal to gamma, n factorial divided by s raised to n plus 1. So this will be the alternate definition, alternate what
this will be the alternate formula for Laplace transform of t raised to n. So we can write this Laplace transform of t raised to n as gamma n plus 1 divided by s raised to n plus 1, or else gamma n plus 1 is equal to n factorial. So using this result, so we can write this Laplace transform of t raised to n as n factorial divided by s raised to n plus 1. Right, so whatever we have discussed, so we have these standard results. So Laplace transform of this a is 1 by a by s, and in particular if a is equal to 1, so Laplace transform of 1 is 1 by s. So a is constant here, so we can write Laplace transform of constant as constant divided by s. Very, very, very important result, because many times we use while solving the example, Laplace transform of constant will be constant divided by s. In particular, if you take a as 1, so Laplace transform of this 1 will be 1 by s. Laplace transform of e raised to 18, 1 divided by s minus a. Laplace transform of cos hyperbolic at, s divided by s square minus a square. Laplace transform of sine hyperbolic at, a divided by s square minus a square. Laplace transform of cos at, s divided by s square plus a square. And Laplace transform of sine at, a divided by s square plus a square. Laplace transform of t raised to n, gamma n plus 1 divided by s raised to n plus 1, or else we can replace this gamma n plus 1 as a n factorial, because we have a standard result gamma n plus 1 is equal to n factorial. N factorial divided by gamma, so n factorial divided by s raised to n plus 1. So observe here, don't confuse this with trigonometric and hyperbolic functions. So cos hyperbolic at and cos hyperbolic at and cos at. So numerator will be same. Denominator for hyperbolic s minus a square. For trigonometric s plus a square, so s square plus a square, right? Hyperbolic s square minus a square, and trigonometric s square plus a square. Please don't confuse. And even in sine hyperbolic and sine at, so hyperbolic function s square minus a square, a will be as it is, and here also uh, denominator s square plus a square for trigonometric. So numerator a will be as it is. Please don't confuse, right? Now with this, we'll solve some examples. So first one, find the Laplace transform of the following functions. Cos hyperbolic square 3t, right? So observe, so we have discussed so far cos hyperbolic at, sine hyperbolic at, but here square is there, but here square is there, right? Again, we can write this cos hyperbolic square 3t as cos hyperbolic 3t raised to 2. Again, we can convert this. We have a property, so I'll take advantage of that. We can convert this hyperbolic function into exponential. I'll take advantage. So cos hyperbolic square 3t is there. In place of a, what we have here? 3. So cos hyperbolic square 3t, this is equal to e raised to 3t plus e raised to minus 3t divided by 2 raised to 2. Right? Because we can write this cos hyperbolic square 3t as cos hyperbolic 3t raised to 2. Right? So cos hyperbolic 3t is e raised to 3t plus e raised to minus 3t divided by 2 raised to 2. Sine means you will get negative. Cos means positive. Middle sign. Right? So middle sign, for sine, you will get sine hyperbolic functions, you will get negative sign, and cos hyperbolic functions you will get here as a positive sign. Please remember this one. Now denominator 1 by 2 raised to 2 will be 1 by 4, because 1 square divided by 2 square is 4, 1 square is 1, 1 by 4, and e raised to 3t plus e raised to minus 3t raised to 2, a plus b whole square, a square e raised to 3t raised to 2 using theory of indices e raised to 60 plus e raised to minus 60 plus 2 you will get, because 2ab, 2, a is e raised to 3t, b is e raised to minus 3t. So theory of indices base is same. E raised to 3t minus 3t plus 3t minus 3t get cancels, e raised to 0. E raised to 0 is 1. So 2 into 1 is 2. Now apply Laplace transform to this. Laplace transform of f of t is equal to 1 by 4. This is as it is. Apply separately Laplace transform to this. So Laplace transform of e raised to 60 plus Laplace transform of e raised to minus 60 plus 2 into Laplace transform of 1, or else 2 is like a constant. So Laplace transform of constant will be constant divided by s. You can write this as directly also, right? So 1 by 4, this is as it is. Laplace transform of e raised to 60, in place of a we have a 6, 1 upon s minus 6 plus e raised to minus 60, 1 upon s plus 6, because we have a standard result e raised to minus 80 is 1 upon s plus a. In place of a we have a 6, 1 upon s plus 6 plus Laplace transform of constant is constant divided by s, or else we can write this constant as constant into 1. So constant taking outside, so constant into Laplace transform of 1, or else you can write directly Laplace transform of a constant is constant divided by s. So 2 divided by s, right? You can stop here only, or else you can take LCM and you can simplify. Now move on to next one. Simple one, e raised to minus 2t sine hyperbolic 4t. So again, hyperbolic function, you convert this into exponential. So we have a property. So take advantage of that property. Use that property. F of t is equal to e raised to minus 2t sine hyperbolic 4t. This is equal to e raised to minus 2t into e raised to sine hyperbolic 4t is there. E raised to 4t, sine is there, negative sign, middle, minus e raised to minus 4t divided by 2. Cos means you will get plus, sine means minus. Only difference is that, right? So 1 by 2, denominator will be as it is. Multiply e raised to minus 2t to this bracket. E raised to minus 2t into e raised to 4t is e raised to 2t, because minus 2t plus 4t. Minus 2 plus 4 is plus 2. So e raised to 2t minus e raised to minus 2t minus 4t. So minus into minus is plus, minus 2 minus 4 will be minus 6. So e raised to minus 60 divided by 2. Now apply Laplace transform to this. Laplace transform of f of t, this is equal to 1 by 2 Laplace transform of e raised to 2t minus Laplace transform of e raised to minus 60. So 1 by 2 Laplace transform of e raised to 2t is 1 upon s minus 2 minus Laplace transform of e raised to minus 60 is 1 upon s plus 6. So take LCM and simplify. You'll get this as 4 divided by s minus 2. 4 divided by s minus 2, s plus 6. Right? Move on to next one. Right? Little bit difficult one. So f of t will be sine phi t cos 2t. Now we have a standard result for Laplace transform of sine at and Laplace transform of cos at. Here we have product of cos and sine functions. So take this as a f of t. So f of t is equal to sine phi t cos 2t. So apply sin A cos B formula. So 1 by 2 sin phi t plus 2t plus sin phi t minus 2t. So phi t plus 2t will be 70. So 1 by 2 will be as it is, sin 70 plus sin phi t minus 2t. Phi minus 2 is 3. So plus sin 3t. So Laplace transform of f of t is equal to 1 by 2. So Laplace transform of sin 70 plus Laplace transform of sin 3t. So in place of a, 7 we have. So a divided by s square plus a square. 7 divided by s square plus 7 square. 7 square is 49 plus 3 divided by s square plus 3 square. 3 square is 9. And this 1 by 2 will be as it is. Right? Now, similar example, it is a product of this three cos functions. So cos t, cos 2t, cos 3t. So cos t, cos 2t. So first simplify. So 1 by 2 cos t plus 2t plus cos t minus 2t. So cos A, cos B formula you apply. So 1 by 2 t plus 2t is 3t, cos 3t, and cos t minus 2t is minus t. Cos of minus theta will be cos theta. So cos of minus t will be cos t, and this plus sign is as it is, right? Now cos t, cos 2t, cos 3t, this is equal to, right, 1 by 2 cos 3t cos t into cos 3t, because cos t, cos 2t will be 1 by 2 cos 3t plus cos t, and cos 3t is as it is 1 by 2. So cos 3t will be this, and plus cos 3t into cos t, right? Apply, multiply cos 3t to this bracket. Now we'll get here as 1 by 2. Again you apply what here, cos A, cos B formula. So we'll get here this as 1 by 2 into 1 by 2 cos 60 into cos 60 plus cos 0 plus 1 by 2 cos 4t plus cos 2t, right? Now this 1 by 2 is common for both the terms. Take it outside, and here 1 by 2 is there. So 1 by 2 into 1 by 2 is 1 by 4. Cos 60 plus cos 0 is 1 plus cos 4t plus cos 2t. So 1 by 4, this is equal to Laplace transform of cos 60 plus Laplace transform of 1 plus Laplace transform of cos 4t plus Laplace transform of cos 2t. So Laplace transform of f of t is equal to 1 by 4. Laplace transform of cos 60 is s divided by s square plus 6 square is 36, plus Laplace transform of 1 is 1 by s, plus Laplace transform of cos 4t is s divided by s square plus 4 square. 4 square is 16, plus s divided by s square plus 2 square, s square plus 2 square. 2 square is 4, right? So this will be the required answer, right? Now move on to next example, sine square 2t plus 1. So f of t will be sine square 2t plus 1. So it is like sine square a. So we have a standard result. So sine square a will be 1 by 2 into 1 minus cos 2a. So using that, in place of a, 2t plus 1. So f of t is equal to sine square 2t plus 1. So this is equal to 1 by 2, 1 minus cos 2t plus 1, because in place of a substitute 2t plus 1. So 1 by 2, 1 minus cos 4t into cos 2 plus sine 4t into sine 2, right? So this equal to 1 by 2, 1 minus cos 4t into cos 2 plus sine 4t into sine 2, right? So here multiply this 2 to this, and cos A plus B formula you apply. So you will get this one, right? Now Laplace transform of f of t, this is equal to 1 by 2 Laplace transform of 1 minus cos 2. It is like a constant because we know what is the value of cos 2, right? So we numerical value will get, means it is like a constant. Take it outside. Laplace transform of cos 4t plus, and this also sine 2, it is like a constant because numerical value you will get in calculator. So within a second you will get the value of sine 2. So it is a numerical value. Take it outside. Laplace transform of sine 4t. So 1 by 2, this is equal to Laplace transform of 1 is 1 by s minus, so this cos 2 constant, this will be as it is. Laplace transform of cos 4t is s divided by s square plus 4 square. 4 square is 16 plus sin 2 will be as it is. Laplace transform of sin 4t is 4 divided by s square plus 16. So this will be the required answer, right? So today I'll stop here only. So if you have any doubts, so you can ask.